All right, let's dive into something really, really cool today. We're talking about a programming language called turtleSpaces, but it's more than that. It's a place where you can literally code your own universe from the ground up. And the whole thing starts with this surprisingly personal thought from its creator. When I was a young child, one of my best friends was a turtle. And believe it or not, that memory of a pet turtle, that's the seed for this entire explainer. This is the story of how that idea of a turtle grew up and learned how to build entire interactive 3D worlds. So what does that actually mean? What can you build? Well, get this. You could code a Star Trek warp effect. Or how about a plane that's trapped flying inside a giant floating torus? You can make animated 3D models of witches and pumpkins for Halloween, build real, interactive games like downhill skiing, or even design landscapes that you can then take and 3D print. This is not a toy, it's a full-on creative engine. Okay, so how can a simple turtle do all of that? Well, to get it, you have to realize that turtleSpaces isn't just about code. It's a playground for your brain, and it's built on a pretty revolutionary idea. The story really kicks off way back in the 1960s. A guy named Seymour Papert, along with Jean Piaget, they championed this idea called constructivism. The gist is simple. We learn best when we're actually building stuff. So Papert and his team created Logo, a language designed specifically for learning. And their big breakthrough, their aha moment, was inventing the virtual turtle at MIT. All of a sudden, code wasn't just abstract text. It was this little guy on the screen you could talk to. And turtleSpaces, it's the direct descendant of that legacy, just brought into a crazy, powerful 3D world. Papert had this amazing name for what he was trying to build, Mathland. And it wasn't a classroom with boring lectures, no. It was a digital playground, a place where you could actually play with ideas like geometry and logic, where you could learn through trial and error by making things instead of just trying to memorize formulas from a textbook. And this is the real magic right here. The turtle creates what they call an empathetic bond. You don't just boss it around. You start to think like the turtle. When something goes wrong with your code, you can literally put yourself in its shoes and figure out the mistake. It makes finding and fixing bugs feel totally natural. So that's the big idea behind it, but how do you actually, talk to the turtle? Turns out it's way easier than you'd think. It's basically like giving it a recipe. Let's say you want to teach it a new trick, like drawing a box. It's just 3 simple steps. First, you give your recipe a name. You start with the word to, so to box. Second, you write out the instructions, the actual steps, like telling it to go forward and turn right 4 times. And last, you just say you're finished by typing end. And that's it. You've literally taught your turtle a new word. Okay, but what if you want the turtle to remember stuff? For that, you use something called a container. And the best way to think about it is like a labeled container for leftovers in the fridge. You make my box 5, and that's like putting the number 5 in a box and slapping a label on it that says my box. Later on, whenever you need that number, you just use .mybox to get it back. Simple, right? Now, as your creations get more ambitious, you can run into problems. Remember that awesome star warp effect? Well, if you keep creating thousands and thousands of stars, eventually your whole universe is going to slow to a crawl. The solution is just so clever, they call it the galactic janitor. It's a built-in feature that automatically cleans up all the old stars that you've flown past and can't even see anymore. And the janitor's secret weapon is a command called tag. What it does is let you group a bunch of things you've made, say a whole wave of stars, under one single name. Then later you can just tell the janitor to erase that one name, and poof, the whole batch is gone. It's a super elegant way to keep things running fast. All right, so we've seen the simple building blocks. Now let's see how you put them all together to build what the creator calls, and I love this phrase, grandiose things. So let's take a whole game, like downhill skiing. The logic might seem complicated, but it's all built from those simple ideas we just talked about. You create a slope, you put down a bunch of trees randomly, and you store their locations in lists, just like our containers. Then you just move the player down the hill, row by row, and at each step you check if their spot matches a tree's spot. If it does, crash. It's an amazing example of how simple rules create complex, fun experiences. Because when you really break it down, a whole game like this is just a few things working together. You've got your rules, the game logic, you've got your graphics, all the 3D shapes, and you've got player input, the interaction. That's pretty much the whole recipe. And this is why the source material makes this bold claim, that Logo is perfect for making these grandiose things that are totally comparable to what you see in Roblox or Minecraft. But here's the kicker. It's all done in a language that is way, way easier to read and understand, because it was built from day one for thinking, not just for cranking out code. And your toolkit for building these grand things, it's huge. We're talking about over 2,000 built-in commands, or primitives, ready for you to use. I mean, just look at this tiny sample. You've got commands for movement, for making complex 3D shapes, for adding sound and music, and of course, for controlling the logic of your program. It's an incredibly deep and rich set of tools. But, and this is important, don't let that big number scare you. All 2,000 plus commands boil down to just 4 simple types. You've got switches, which just turn things on or off, settings, where you define a value, like a color, calculators, which give you back a result, like adding 2 numbers, and performers, which just do something, like move the turtle forward. It's all neatly organized. So when you put it all together, you realize turtleSpaces isn't just a programming language. It's a whole creative ecosystem. It's a universe filled with turtles, other little workers, 3D models, sounds, even spaces that can link to other people's spaces. And that brings us right back to the beginning. Pappert's whole goal was to create a language that was designed not just to code, but to help you think. So that leaves us with the big question. If you had a tool like that in your hands, a tool for thinking, what worlds would you build?